power rule. If f of x is x raised power n, where n is a real number, then f prime of x is equal to n times x raised power n minus 1. Dear students, the next rule is constant times a function. If f of x is equal to c times g of x, where c is constant and g is a differentiable function, then f prime of x is equal to c times g prime of x. Next rule, sum or difference of function. If f of x is equal to u of x plus minus v of x, where u and v are differentiable functions, then f prime of x is equal to u prime of x plus minus v prime of x. Product rule. If f of x is u of x into v of x, where u and v are differentiable functions, then f prime of x is equal to u prime of x into v of x plus u of x into v prime of x. Dear students, the next is quotient rule. If f of x is u of x divided by v of x, where u and v are both differentiable functions and v of x is non-zero, then f prime of x is equal to v of x into u prime of x minus u of x into v prime of x divided by v of x whole square. Example: differentiate the following function. F of x is equal to 15x raised power 100 minus 3x raised power 12 plus 5x minus 46. To differentiate the given function, we need to remember the first and second rule of differentiation, that is constant function and power rule. So we get f prime of x is equal to 15 times 100 x power 100 minus 1 minus 3 times 12 x raised power 12 minus 1 plus 5 times 1 x raised power 1 minus 1 minus 0. That is f prime of x is equal to 1500 x raised power 99 minus 36 x raised power 11 plus 5. Dear students, next we see another example. The position of any object at any time t, which is given in hours, is given by s of t, that is equal to 2t cube minus 21t square plus 60t minus 10. Determine when the object is moving to the right and when the object is moving to the left. To determine the direction of the object, we need to determine the velocity of the object. If the velocity is positive, this implies the direction of the object is moving off to the right. And if the velocity is negative, this implies the direction of the object is moving to the left. To determine the velocity, we derivate the given function. So we get s prime of t is equal to 2 times 3t raised power 3 minus 1 minus 21 times 2t raised power 2 minus 1 plus 60 times 1t raised power 1 minus 1. That is s prime of t is equal to 6t square minus 42t plus 60. So if we factorize, we get s prime of t is equal to 6 times t minus 2 times t minus 5. The intervals at which the velocity is positive or negative is given by s prime of t. First, positive at minus infinity is less than t is less than 2 and 5 is less than t is less than infinity. That is when t is between minus infinity and 2. Also when t is between 5 and infinity, it is positive. For the second step, it is negative when t is between 2 and 5. Hence, the object is moving to the right over the interval minus infinity to 2 union 5 to infinity, and the object is moving to the left over the interval 2 to 5. Dear students, now we see another example. Differentiate the given function f of x is equal to 6x cube minus x into 10 minus 20x. To differentiate the given function, we apply the rule 5, that is the product rule. So f prime of x is equal to u prime of x into v of x plus u of x into v prime x. So we get f prime of x is equal to 6 times 3 x raised power 3 minus 1 minus 1 time 1 x raised power 1 minus 1 into 10 minus 20x plus 6x cube minus x times minus 20 multiplied by 1 x raised power 1 minus 1. Now we simplify and we get f prime of x is equal to 18x square minus 1 multiplied by 10 minus 20x plus 6x cube minus x multiplied by minus 20. So after further simplifications we get f prime of x is equal to minus 480x cube plus 180x square plus 40x minus 10. Dear students, now we see another example for the quotient of two functions. Differentiate the following function f of x is equal to 3x plus 9 divided by 2 minus x. To differentiate the given function, we apply the rule number 6, that is called the quotient rule. So we get f prime of x is equal to u prime of x into v of x minus u of x into v prime of x divided by v of x square. So we get f prime of x is equal to 3 times 1 x raised power 1 minus 1 multiplied by 2 minus x minus 3x plus 9 multiplied by minus 1 times 1 x raised power 1 minus 1 divided by 2 minus x whole square. So after simplification we get f prime of x is equal to 15 divided by 2 minus x whole square. Dear students, now we see further rules for differentiation. Power of a function. If f of x is equal to u of x raised power n, where u is a differentiable function and n is a real number, then f prime of x is equal to n times u of x raised power n minus 1 times u prime of x. Base e exponential function. If f of x is e raised power ux, where u is a differentiable function, then f prime of x is equal to u prime of x into e raised power ux. Natural logarithm function. If f of x is equal to ln of ux, where u is a differentiable function, then f prime of x is equal to u prime of x divided by u of x. The next is chain rule. If y is equal to f of u is a differentiable function and u is equal to g of x is another differentiable function, then dy by dx is dy by du times du by dx. Example. Use the chain rule to differentiate the given function. The given function is y of x is equal to 5x minus 8 square root. Using the chain rule, we need to identify the two functions that we need for composition. First function is f of x, which is x square root, and the second function we can take is g of x, which is equal to 5x minus 8. Now, f prime of x is 1 divided by 2x square root, and the derivative of second function is g prime of x, which is equal to 5. Now using the chain rule, we get y prime of x is equal to f prime of g of x into g prime of x. So that is f prime of 5x minus 8 into g prime of x. So f prime of 5x minus 8 is 1 over 2 5x minus 8 square root times g prime of x, which is 5. So after simplification we get y prime of x is equal to 5 over 2 5x minus 8 square root. Dear students, now we see another example. The demand equation for a certain product is P, which is given by 6 minus half x dollars. Find the level of production that results in maximum revenue. The revenue function R of x is given by R of x is x times P, which is equal to x times 6 minus half x. So after simplification, we get revenue function R of x is equal to 6x minus half x square. The marginal revenue is given by R prime of x, that is we differentiate R of x, so we get 6 times 1 into x raised power 1 minus 1 minus half into 2 times x raised power 2 minus 1. So we get r prime of x is equal to 6 minus x. The graph of r of x is a parabola that opens downward. It has a horizontal tangent at x for which r prime of x is equal to 0. That is, for those x at which marginal revenue is 0 is at x is equal to 6. Hence, the corresponding value of revenue is r of 6. So we calculate r of 6 and it is given as $18. Thus, the rate of production resulting in maximum revenue is x is equal to 6, and which results in the total revenue of $18 when x is equal to 6, and it is shown in the graph. On the x-axis we have x is equal to 6 shown in the dotted blue lines, and similarly on the y-axis we have revenue which is in dollars and it is also shown in the blue dotted lines. The derivatives can be interpreted as instantaneous rate of change. The average rate of change of a function y is equal to f of x from x is equal to a to x is equal to b is defined by average rate of change and is equal to f of b minus f of a divided by b minus a. Dear students, now we see another example. Suppose a company's total cost in dollars to produce x units of its product is given by C of x, which is equal to 0.01 x square plus 25x plus 1500. Find the average rate of change of total cost for the first 100 units produced from x is equal to 0 to x is equal to 100, the second 100 units produced. First we solve the first part. The average rate of change of total cost from x is equal to 0 to x is equal to 100 units is given by C of 100 minus C of 0 divided by 100 minus 0. So this is equal to, we put the value of x is equal to 100, then we put the value of x is equal to 0, then we subtract and divide it by 100. So we get C of 100 minus C of 0 divided by 0, which is equal to 4100 minus 1500 divided by 100. So after simplification, we get this equal to 26. Hence, the average rate of change of total cost from x is equal to 0 to x is equal to 100 is $26 per unit. Secondly, the average rate of change of total cost from x is equal to 100 to x is equal to 200 units is calculated as C of 200 minus C of 100 divided by 200 minus 100. So to x is equal to 200 units is C of 200 minus C of 100 divided by 200 minus 100. So after simplification, putting the value of x is equal to 200, then putting the value of x is equal to 100, and after subtraction and simplification we get equal to 28. Hence, the average rate of change of total cost from x is equal to 100 to x is equal to 200 units is $28 per unit. Dear students, now we see the higher order derivatives. First of all, we talk about the second derivative. The derivative f prime of a function is referred as the first derivative. The derivative of the function f prime, which is denoted by f double prime, is referred as second derivative. Third and higher order derivatives. The derivative of a function of second order derivative is referred as third derivative. The nth order derivative of f, denoted by fn, is found by differentiating the derivative of order n minus 1 at x. That is, fn of x is equal to d by dx of fn minus 1 of x. Dear students, now we see an example to calculate the higher order derivatives. Find three higher order derivatives of the given function f of x is equal to 16x cube minus 4x square. First of all, we calculate the first derivative, and it is given by f prime of x is equal to 48x square minus 8x. Then we calculate the second derivative, which is given by f double prime of x is equal to 96x minus 8. And then we calculate the third derivative, which is given by 96.